problem of the day, LCP. So geek is at the Geek Summer Carnival. He is given an array of n strings. To unlock exclusive course discounts, he needs to find the longest common prefix. So LCP means longest common prefix. Okay. So to unlock exclusive course discounts, he needs to find the longest common prefix among all strings present in the array. Can you help him? So we have geeks for geeks, geeks, geek, and geezer. So let's say we have G here. Okay, we have G here, we have G here, we have another G. Okay, we have E, 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 another E, 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 E. Then we have K here. Okay, that's fine. We have K here. That's also fine. We have another K here. Perfectly fine. But here it's set. So that will not be counted towards the longest common prefix. And the common prefix is GZZ. Sorry, GEE. So GE is the longest common prefix in that example. The one is apple, AP, ape, April. So A. That's perfectly fine. P, perfectly fine. But this one is P, this one is E. There itself, it's over. The game is over. That AP is the answer. And this is also the different one. So that's what we need to find the longest common prefix of all the strings given in the array. So let's take the example. So geeks for geeks, we are having, say, okay, let's have the characters here. Geeks for geeks, then we have geeks, then we have geek, then we have geezer. So this is the array that is given to us. So in a very brute force approach, what we will do, like we can just consider the first string alone. Okay, then go to the next string and find like whether G they are equal, whether this E equal, whether this K equal, like that. Like we can find that. Okay, we are done with it. Then we will look for this one, these two strings, and we will also find the longest common there, and for the string, and that's might not be enough. Now we need to look for this one, and for this string, that will also be sometimes not enough. We also need to look for this. So the time complexity will be like a quadratic, or what we can say, it's very big. So that's not a better idea. So how can we do this? What if we sort this array? What if we sort this string array? After sorting the string array, what will be the result that we will be getting? So applying sorting inside the string array makes the array to be in the lexicographically increasing order, or the smaller order. So what the lexicographical like that order means? So it will be smaller, like the first position where a particular character differs, that two characters will be considered for the sorting. Suppose we have some A, B here. Okay, we have another string A, C here. Okay, so A is same here, fine. A is same here, that's also fine. A is same here, perfectly fine. But now let's look this B and C. Here B is less than C. So what we can say, A, B is lexicographically smaller than A, C. So like that order will be arranged after we apply sorting. So for this given array, when we do the sorting, the result will be something like, let me make this, this will be the smallest, geek will be the smallest, then geeks will be the next one. Okay, so this is the first place where it differs, and this is smaller than this geeks. Now we have these geeks, and then geek for geeks will come. Okay, geeks for geeks. And what about this geezer? Okay, about this geezer, G is same, E is same, E is same, and now we have a difference in this K and Z. Okay, these many characters are same for all the like GEEK, GEKS, GEKS. So up to K, for the first three characters up to K, it's perfectly fine. But when it comes to the last string in our array, it's geezer, we are having Z or Z. At that time, what we can say, our K is less than Z. So geezer will be greater than geek, geezer will be greater than geeks, and geezer will be greater than geeks for geeks also. So our last will be what happened? Okay, our last will be geezer. Okay. Last will be, sorry about that, something happened, geezer. So like this our array will look like after sorting. Okay, so geek, geeks, geeks for geeks, and geezer. Now what we need to do, we need to just compare the first, which will be the smallest lexicographical string, and the geezer, the very last one, which is the largest lexicographically ordered string. We just consider only those two. Let's take those two only, geek and geezer. Now you can find the what we have to do. We need to apply 2 pointers, one pointer pointing here and the pointer pointing here. It's not 2 pointer, let's say 2 variables. Okay, and one pointing to geek, the first position of first index of the string geek, the other pointing to the first index of geezer, and we just compare whether G is equal to G. Yes, G is equal to G, so we just add that into our result. Now we move our pointer in both strings, so E is equal to E, so we add it into our answer. E is equal to E, that also gets added into the answer. Now we have K, Z, which is not equal. At that position we just break. Okay, because there is no, even though there is so many strings, still strings left in the smaller string, there is no like logic in further continuing to check for this, because we need to look for the prefix, common prefix, and it ends here, and we noted the string, and this will be the longest common prefix, so we will be finally returning this one. Sometimes there can be cases where every strings are different, so there will not be any common prefix at that time. Like we need to return whatever it's told here. It's not specified. I think it needs to be returned -1. Most of the cases is -1 in geeksforgeeks. Yeah. So that's the idea. Let's also look for the next example. Okay. Let's also do the second example. It's apple, ape, and resulting string will be A, P, P. And where is the first place that we are having the difference? Here E. Okay. So after A and P, we are having a difference. Here one is E, the other string is P, the other string is R. Okay. And E is less than P and P is less than R. We can say A, B, C, D, F, G, we all know. So P, Q, R, S, T. Yeah, fine. E is less than P, P is less than R. So how our string gets arranged? Ape will come first, then apple, then April. So now we got that's ape, apple, April. Okay, now we got the smallest string and the largest string. So let's consider only those two strings, which is ape and April. Okay, that's fine. Now what we need to do, let's have two variables, one pointing to the first index of ape, the other pointing to the first index of April. Let's have A and A are equal, so let's store that character, move the pointer. We have P and P equal. Okay, perfectly fine. So we also move that. Now E and R, which is not equal, so we just break, and whatever we are having at the end will be returning this. If it is not if the length is not equal to 0. The length is not equal to 0 means we didn't find, if the length is equal to 0 means we didn't find any string which is the common prefix, is having the common prefix. So that case, like, we need to return some -1 like that. So this is the approach. So the first step is sort the given array, take out only the smallest string and the largest string, take two variables, index variables, one pointing to the first index or the 0th index of the smallest, 0th index of the largest, continue storing the characters when both of the string is having the equal characters, and break when there is a change or when there is a difference, and finally return whatever we stored. So that's the concept. So what if the length is equal to 1? There is only one string. We can just return the first string itself, like, yeah. Now we are just sorting. Okay, fine. We sorted. Now we got it in the lexicographical order. Take the smallest string, okay, which will be at the first index. Take the largest string, which will be at the very end, which is s of n-1. Let's also take the lengths, the respective lengths, which will be useful while traversing. Int largest length, string length. Okay, let's name it smallest string length, largest string length equal to largest string dot length. Okay, fine. Now I'm making use of a string builder, okay, in order to track the result or the common prefix. Let's have two pointers. Let's say int I is equal to 0, j is equal to 0, both pointing to the 0th index of smallest string and largest string. Now while I is less than smallest string length and j is less than largest string length, it's perfectly fine to include both of this. Okay, no wrong in that. So so if there is any difference, we need to break. So let's write that condition first. So if smallest string dot caret of I is not is equal to largest string dot caret of j, so there is a difference, we break. Otherwise just store it, smallest string dot caret of I plus plus j plus plus. Now let's store whatever we have in our string builder to the final result string, is equal to sb.toString. Now we need to have that special check, like if the result string's length is 0, that means we didn't find any common prefix. At that time we need to return -1. It's not specified here, but let's go with the -1. So otherwise we will be returning the result string. So return result string dot length, if it is equal to 0, let's say -1. Okay, otherwise result string. So the time complexity will be, we are sorting the whole array. So if the length of the array is n, so the sorting of the whole array will give us NlogN, and this is also a plus. We will be traversing for a maximum of the smallest string length. So big of smallest string length, that will be the time complexity. So overall time complexity will be big of NlogN. And space complexity, if we consider this, like, it will be big of length of the result string, whatever will be the longest common prefix. If we do not consider this, then we can say like it's a constant space complexity. Otherwise it will be whatever will be the length of this result string, that will be the space complexity. So let's run this program. Okay, gigi, okay, submit. Yes. So that's the idea for the longest common prefix. Just sort, take the smallest string, which is the lexicographically smallest string, take the largest string, which will be the lexicographically largest string, just go through the characters, right? Let's also check like whether we actually need to do this and according to my logic, like it might not be required, but just reconfirm that. Okay, what if we submit? Yeah, that's fine. So even though like we neglect that condition, this enough. Like we the at most we will be traveling through the small string length only. Yeah, so that's fine. So that's the problem.